segment, you can say 10 number of segments, okay, or partitions also. Each partition will store one process. So suppose you have 10 process, you are going to store in the 10 number of partitions. Degree of multi-programming limited by number of partitions. Okay, so degree of multi-programming is actually determines the number of partitions. Is determined by the number of partitions. Okay, so how many partitions are there? That will tell what is the degree of multi-programming. Whether multiple programs can be executed by the computer or not, that will be dependent on the number of partitions. If a partition is free, load process from the job queue. Okay, this is possible, and MFT IBM OS360. This example is shown here. Okay, this is an example shown here to tell about the multi-partition or multiple partition allocation. So that is shown here how multiple partition allocation is there. Okay, there is only one operating system and one particular space here. There is the space for 3 number of processes. There is a space also for the 3 number of processes. But you see, whenever a particular process, suppose this process 8 is not present here, initially suppose there are 3 number of processes, process 5, process 8 and process 2. And after some time, process 8 suppose leaves this memory space. Okay, then process, any other process can be allocated there, and as they are not the fixed size partitions. Okay, they are the variable size partition. You can take a particular portion to store the memory. The process. Okay, so process 9 is lower size than the process 8. Okay, so process 8 took the whole address space, whole partition, but when the process 9 came, it took only some portion of the address of the partition, and the remaining partition is actually kept blank. So any process that is that may fit in this particular location, they may come and they may be allocated in the particular partition. Okay, so process 10 came there and it will be stored in the location that is after process 9. Okay, so this is the advantage of the variable partition. If you have the variable partition, okay, or multiple partition, then only you can do this thing. But if you have the fixed size partition, then this will not be allowed here. Okay, so you know that the free partitions are known as the whole, and allocated partitions are the partitions that are shown here. Okay, whenever you are going to store some data in the memory, then there are 3 different types of algorithm. That is called the dynamic storage algorithm. One is the first fit algorithm. First fit, then best fit, and then worst fit. First one is the first fit. First fit means that if you have, suppose, for example, this one. So any process, suppose you have 5 processes and you are going to store the processes one by one in the memory location. Now the first fit will tell that if the first cell is free, you just keep the process in that particular location. Okay, it will not check the best partition. What will be the best partition? The best partition will be the partition size, when the partition size is same as the process size. Okay, if you are going for the allocation like best the first partition, suppose the first fit, then you have suppose stored in a particular location, but finally you are seeing that some other partitions were there you can store the particular process, and that will fit well. Okay, so this thing is available, so this first fit, best fit means that the whole size and the process size will be same. Okay, or that will fit exactly. Okay, but the first bit will tell that you have to store the process in the first hole, and therefore you are not going to check some other holes whether they are able to take the particular process or not. Okay, and worst fit means that they will be actually allocating the process in the largest hole. Okay, so that is not a good thing. Okay, if you are going to store the process in the largest hole, then that will be you have to find the largest hole, from there you are just going to allocate that process. But the problem will happen there that you are not going to check the best process. Okay, best process, you are not going to check the best particular location where you can keep your actual data. Okay, or the process. Now the relocation register is there. So up to this, any problem, anyone, any question?
No, sir.
Someone is telling in the chat. You may tell here directly, because I'm not going to the chat. Okay, no chat is here. So the relocation register. Now, this relocation register is used to protect user processes from each other. Okay, and from changing operating system code and data. So this thing is important here. That means if you have multiple user processes, how so that are present in the same memory location. Okay, but there are suppose multiple partitions. Okay, in a memory there are suppose multiple partitions, and in that partitions you have stored multiple user processes. Okay, now their security is important here. So what we are doing here, we are just going to if you are going to just uh, protect them, protect the user processes, or you are suppose changing the operating system code and data. Okay, in that case this relocation register is required, where this relocation register will contain the smallest physical address, and the limit register will contain the range of logical address. Okay, so the relocation register is containing the smallest physical address, and the limit register is containing the range of the logical address. Okay, each logical address must have less than limit register. This thing. Next one is the context switch. So context switch term, I have told that thing that suppose you have allocated one process in the CPU. If you are taking the process from the CPU and allocating some other process in the CPU, that we do generally in the case of preemptive version like SRTF, round robin, etc. So that is called the context switching, that the processes are coming into the CPU or coming out of the CPU, okay, during the execution time. That thing happens also in the case of memory. The process may be going to the memory or may be leaving the memory. As we have seen this thing, this figure, this process 8 left from this location. Okay, so why this is happening? That you are going to free the partition. Okay, you are going to free the partition, and that partition will be freed. Okay, the process will be leaving the main memory. Same thing is happening here in the by using the context switching. You can switch some process from main memory also. Okay, and this MMU, that is the memory management unit, maps the logical address dynamically. So here in the diagram you can see that instead of the previous one, that means we have shown this diagram, we are going to implement, we are going to just change this thing, just we are going to change. So this one is the first diagram that we have shown here, then the second diagram we have shown here, the third diagram we are showing here. We can see that this relocation register is coming extra here. So first of all, the CPU has generated the logical address. That is the first thing. Then, so this question may come in the MCQ part, that CPU generate which address? Number one, logical address. Number two, physical address. Number two, store address. Number three, some other address, relocation address, suppose this thing. Okay, so you have to tell that logical address. This will be the answer. I may give for understanding or for some other meaning, that is that this is the virtual address. I may write virtual address. Okay, so if I write virtual address, then virtual address you have to choose. If I write logical address, then you write logical address. Okay, the logical address and the virtual address are the same thing here. Okay, the term. Now, so now this limit register is there, that is actually telling the limit value, and the relocation register is there, that value. So first of all, the logical address should be checked whether it is less than or not. Okay, this limit register means the logical